Imagine our project is to create a prototype of a Mars robot. We have discussed the scope with our stakeholders. We created a work breakdown structure like this. We made estimates. We determined the dependencies between tasks. We basically followed a traditional planning process to plan our project. We have entered it in our scheduling software. In this demo, we'll use Link Steinfro for that. In the Portfolio tab of the desktop window, we just see one project. It's our project, Mars Robot Proto. When we open it, we get into the project window. Let me first introduce you to the user interface to make you familiar with it. On the left, you see the task window, and it shows the tasks of the work breakdown structure. In the middle, there is a graphical window for the Gantt chart. And at the bottom there is a task property window with several tabs for different properties of the selected task. And in this case we have selected task number 4, engineering. Below the task properties window you see the timestamp. Today it's Friday the 7th. During the demo we're going to change the date a number of times, and we do that by clicking on it. If the project starts today, it will be finished on March 27. In total 35 days. In the critical chain view you see only the tasks that determine the duration of the project. You find it helpful if you need to shorten the duration of the project, and then you just have to focus on these tasks. And if one of these tasks delays, then your project also will probably delay. So these are the most critical tasks of your project. We haven't assigned resources yet, so that's what we're going to do right now. And for that we use the side window. It's very easy. Assigning resources can be done just by dragging and dropping like this. Now see what is going to happen right now. You see there is no dependency between the different hardware tasks. So we could do them simultaneously if we would have enough people. If I assign the same resource to these tasks, then you see that the project is rescheduled. Because Mick Jagger can't work simultaneously on all these tasks. The project takes longer and longer as more tasks get scheduled after one another. It is called resource contention when tasks must wait when people are still working on other tasks. Our planning software changes the color of the task to red when tasks become part of the critical chain. And this makes it very easy for you to focus on the most critical task of your project. When we have assigned resources to all the tasks, the planning looks like this. The end date is now April 24th. That has all to do with resource contention. And the critical chain looks like this. The critical chain is the first of the most appealing tools of the critical chain project management toolbox. The purpose of the critical chain is to prevent that you create schedules for which you don't have enough people to get all the work done in time. And exactly this is one of the main causes for problems in projects. Not enough people and people with not enough time. And the critical chain helps you to prevent this. And that's important. Maybe the critical chain is the most important contribution of critical chain project management to project management. The second tool of critical chain project management I'd like to introduce you is the buffer management. Normally, all tasks in project contain some sort of safety to absorb uncertainties or fluctuations or surprises. This happens automatically and people do it without thinking. It is to avoid that you have to break your promise if something unexpected happens. Well, to avoid delays completely, you should add huge safety margins. And of course that is not possible. So although most tasks will be completed in time, some tasks will be late. Despite the safety reserves, buffer management helps you to better complete your projects in time when some tasks need more time than their safe estimate. Buffer management makes it possible that people who don't need all their safety reserve transfer it to people who need more time to complete their tasks in order to complete the project in time. Creating a critical chain plan is not so difficult. We start with converting a safe schedule to an aggressive schedule. An aggressive schedule is a schedule with less safety reserves. And we can do that easily by shortening the duration of the task. In this case, we take 33% of the task duration as a safety. We reduce the safety of all tasks in this project by just shortening the task time duration for each task. Now we have an aggressive schedule that contains less reserves. Although some tasks might still be in time, most tasks won't. This aggressive schedule isn't realistic anymore. So now we add all the reserves that we took and we add it to the end of the project and put it in the project buffer. That brings us back to the same end date as we had before. Well, what has changed? The benefit of this is that the people who don't need their reserves don't waste it anymore. And it can now be used by others who need more time to complete the task. Many success stories from all around the world demonstrate that this way of working, this way of planning works and dramatically increases the reliability of project. The meaning of the other buffers in the middle of the project, how it works exactly in detail, and how this affects the way your people work, that will be part of one of my later videos. The calculated end time is now March 29. That is based on the aggressive schedule. And on top of that comes the buffer of 19 days. And that brings us to April the 25th. When we started with our safe schedule, it was April 24th. The difference is just 0.3%, and it's because of rounding issues in this demonstration. And this completes a critical chain project with buffers. Now let's see how that works during project execution. After the release of the project properties, resource contention is made visible. It shows tasks that could start earlier, but resources are not yet available because they are working on other tasks. You see that the availability of Mick Jagger delays the start of Wheels, and that the antenna is delayed by Ron Woods because he is still working on task number 17, Facility. After the project is released, people start working on tasks. Right now I simulate a couple of days' work by changing the date a couple of times and to report progress. For the first task we gave a new estimated time to complete. Every day, every reporting day, you must tag the status. You see the remaining duration of task 2. And the rest of the project is scheduled based on the progress of task 2. Meanwhile, the end date remains fixed and the project buffer stays in place. Now there is a small overlap between the project schedule and the buffer. There is 9% less buffer available to complete the project, but that is all fine in this stage right now. And I'll introduce you to the most powerful progress chart there is, and that is the fever chart. It looks like this. Each dot in the diagram is a tagged status update. Progress to the right reflects less time to complete the project. When the line moves up, it reflects that the project buffer is consumed. We saw that 9% of the project buffer is eaten. Now let's assume we fast forward 1 week and we just continue to work the way we did to finish our first task. So now let's see what the fever chart is saying. In the fever chart you see the line went further up. When we stay in yellow, it means that we work in line with the safe planning, which is great, we'll deliver in time. Now let's assume that one of the engineers got ill for a couple of days and that we have no replacement for him. Then on February 21st, the fever chart looked like this. The estimated time to complete isn't changed because no work has been done. So there is no movement to the right. While the time progressed, the end date isn't changed, there is less time available in the project buffer. So a line in the vertical direction indicates a period of no progress at all. And now we are in the red. If our engineer starts to work again and he will work according to his safe estimates, then we will be late. So we must take action. Red means immediate action. Now again, 1 week forward. During this week, our team succeeded to make progress exactly according to the aggressive schedule. So that means that we didn't need any project buffer. So the line doesn't go up. Well, the estimated time to complete is shorter and shorter, so we're moving to the right. And a horizontal line means that we work according to the aggressive schedule. We're now back in the yellow. If the project would be executed in line with the safe schedule, we will remain in the yellow and we deliver the project in time. Again, we move forward a couple of days. And look what happens right now. Based on this graph alone, I can't tell what it is. Maybe our client wants to have more functionality, or a design team find out about requirements they overlooked before, or we figured out that our estimates weren't correct. But the impact is there is more work to do. So we move backwards, to the left. We also move up, because more work with the same deadline means less buffer. So we move up. This is the project situation right now. The end date of the project is still April 25th. We have consumed 54% of the buffer already, while we completed less than 25%. Without further action, our project will be late for sure. And something must be done.